For the first set of notes for our class, we are looking at just the basics of statistics, some of the fundamentals that you're going to have to know as we build throughout the rest of this course. Now, you guys probably already have a pretty rudimentary idea of some of the fundamentals and some of the basic principles of statistics. What we're really going to be focusing on right now are how to categorize different types of statistical studies, and also the different types of statistics that may exist. So the first one that we have descriptive statistics, and then we have inferential statistics. When we talk about descriptive statistics, we are looking at a complete set of data. So we're looking at every possible value that could be made up or that could comprise any given data set. So right here you kind of have a little bit of an example talking about the 1948 Washington Senators baseball team. They played 153 games, they won 56, they lost 97. That is a descriptive statistic because we are taking into account every single game that they played. We're not just looking at a few of the games over the course of the season and then making a prediction or an inference based off those values. We are looking at every possible piece of data that is available, and that's that they played 153 games. They were led in hitting by Bud Stewart, whose batting average was 279. So that again is another descriptive statistic because they took every single at-bat that Bud Stewart had, and every time he got a hit, that counted as in one column. We'll just say we had two columns. We had hit, no hit. So when Bud Stewart went to bat, if he got a hit, they put a tally mark in the hit column. If he didn't get a hit that at bat, then they put a tally mark in the did not get a hit column or no hit column. So what this tells us is that 27.9% of the time, Bud Stewart got a hit when he was at bat. Again, this is a descriptive statistic because it took into account every time that he went to bat. We didn't just randomly pick certain games that he played in and evaluate that information and then make an inference for the remainder of his season on how he may hit during that any given game. So again, descriptive statistics takes into account every conceivable bit of information that you have. Think about free throws. If we say that somebody is a 82% free throw shooter, what we're saying is based on everything up to that point in time, every time that individual went to the free throw line, they have made 82% of their free throws. If we took a sample of that individual's free throws, then we're making what we call an inference, and we're going to talk about that here in a minute. But just keep in mind, descriptive statistics do take into account all of the data that is available. Here's a definition that might be helpful. Descriptive statistics consists of methods for organizing and summarizing information. And descriptive statistics will include or can include the construction of graphs, charts, and tables, along with the calculation of various descriptive measures such as averages, measures of variation, and percentiles. And we're going to talk about a lot of those in greater detail as we go on throughout the course. So inferential statistics is where we take some of the values that we are provided with and we make predictions based off of what we think we know. We're going to stay back in the 40s here, and we're going to look at the 1948 presidential election. And this one is interesting because statistics actually failed in this election. But during the election, President Truman was concerned with whether or not he was going to win re-election. And the Gallup poll that was taken just prior to the election predicted that he would win only 44.5% of the vote and be defeated by Thomas E. Dewey. However, the statisticians had predicted incorrectly. Truman ended up winning more than 49% of the vote. In the Gallup organization, they ended up modifying some of their procedures, and they have correctly predicted the winner ever since, with the exception of the 2016 election. So let's talk about what happened there just for a minute. The Gallup poll made a prediction that Truman would only win 44.5% of the vote and then subsequently be defeated by Thomas Dewey. They made that prediction off of a sample of all United States citizens. So what they did is they contacted certain people within the population, asked them which way they were going to vote, and when those people indicated which way they were going to vote, they kept a record of that. They did not ask every United States citizen that was of voting age. So the difference between the descriptive statistics, we're talking about the batting averages, for example, we've taken into account every time the person went to bat. With inferential statistics, we are just looking at a small portion of a population. It's not feasible to do a complete sample of the entire U.S. voting population, because then they would have known exactly what the end result would be of the election. So in order to save time and money, the Gallup industry or Gallup Corporation, what they did was contacted individuals within different groups. They may have contacted, say, 1,000 people in the state of Kentucky, 1,000 people in Tennessee. And based off the results of these contacts, they made that prediction, and in this case, it was incorrect. If you guys recall the 2016 election, it was widely expected that Hillary Clinton was going to win that election. Nobody thought that Donald Trump was going to win. I even think that I remember seeing a Gallup poll that said that they predicted that Hillary Clinton would win almost 90% of the popular vote. And that's pretty extreme. I could be wrong about that, but I do know that it was very high. And we all know how that election ended up turning out. Donald Trump did win the election. Granted, he didn't win the popular vote, but based upon the Electoral College, he did win the election and went on to become our president. So when we talk about inferential statistics, like I mentioned earlier, if they interviewed everyone of voting age in the United States, it's going to be very expensive and unrealistic. We're not talking about conducting the actual election. We're just talking about doing a poll to find out how the election may play out. So it's not feasible financially or with the time constraints that they may have to go out and interview every voting aged member of the United States population and find out what way or which way it is that they're going to vote. So what they would do is choose a small sample of the population, in this case maybe just a few thousand voters, but they want to make sure that they choose a representative population of the United States. Let's consider Perry Central High School. Perry Central High School, we're all well aware, is roughly 95% white. The other 5% is made up of other races. So if somebody came in here and interviewed let's say they took a poll of every student at Perry Central High School, that poll would not be a representative poll, because we're talking about a population within the school that is 95% white and 5% comprised of other races, whether it be Asian, African American, or even mixed races. The results of the poll at Perry Central High School would be far different from, say, a school that was in inner city Chicago, where the population is traditionally almost probably 95% African American, and then 5% Caucasian, Asian, or other mixed races. So when we talk about taking a representative sample, we want our sample to represent the entire population that we are surveying. So for the sake of argument, let's say that the United States is 63% white, and 27%, 27% African American, so that's 90% right now. And then we'll go with 10% Asian, Hispanic, and other races. These are not actual values. This is just something I'm making up. So then when we conduct our sample, which is a smaller portion of the population, should have those same values. We should have 67% white, 23% African American, and then 10% Hispanic, Asian, and other races, just so that we can get a better idea of the population that we're trying to make predictions about. So anytime we have a group that is not the entire population, that group is called the sample of the population. And then we can take the results of our sample poll and we make inferences about the entire population as a whole, and that's where we get the term inferential statistics. So here's a definition of population and sample. Population is the collection of all individuals or items that are under consideration. So if we look back at the election, that would have been all voting age members or voting age people in the United States. The part of the population from which we obtain the information that we use to make inferences with is called the sample. So whoever the Gallup poll talked to, which wasn't the entire voting age population of the U.S., whoever they spoke to gave them their sample data. They took that sample data and they made inferences. Now, in the case of the 1948 election, the inferences that they made were incorrect. Truman did, in fact, end up winning that election. So inferential statistics, it consists of methods for drawing and measuring the reliability of conclusions about a population. So we're talking about a population, but we're basing that information on a sample of the population. When we talk about different types of studies, we have a couple of different things we're looking at. We're looking at observational, and we're looking at experimental. So before we go on with that, let's look at this first example. And all we're going to do is determine whether or not this is descriptive or inferential. And here in example 1, we have a table that shows the voting results of the 1948 presidential election. We're going to use this information to classify the study as either descriptive or inferential. So this first column, this shows the number of votes that each candidate received. The second column shows the percentage of the total votes that candidate ended up receiving. What we want to pay attention to when we're trying to classify this is that first column shows the exact number of votes that each candidate received. It's not a sample of the number of votes that the candidate received. So since this is all the votes that were cast in this election, we can define this one to be a descriptive study. Because it takes into account every single vote cast. When we look at example 2, we're going to do something very similar. We're going to determine whether or not this is descriptive or whether or not it is inferential. And the example that we're given, they're talking about the Major League Baseball from 1876 to 1977. We're using baseballs produced by the Spalding Company. In 1977, Spalding ceased manufacturing Major League Baseballs. And then so the MLB returned to the Rawlings Company. So early in the 1977 season, this is when the new baseballs were being used, pitchers began to complain that the Rawlings baseball was livelier than the balls produced by Spalding. They claimed that it was harder, it bounced farther and faster, and that it gave hitters an unfair advantage. And so it turns out in the first 616 games of 1977, 1,033 home runs were hit, compared to only 762 in the same number of games during the previous season. The so Sports Illustrated, they actually conducted a study of their own, and they published an article called "They're Knocking the Stuffing Out of It." That's what we see right here. That's the name of the article. And I will be posting this article on the website if you do want to read it. And in the study, an independent testing company randomly selected 85 baseballs. So let's make a note of this. They randomly selected 85 baseballs from the supplies of various MLB teams. So the company measured the bounce, weight, and hardness of the chosen baseballs and compared them to similar tests that were conducted in 1952, 53, 61, 63, 70, and 73. Their conclusion was that the 1977 Rawlings baseball is livelier than the 1976 Spalding, but not as lively as it could be under MLB rules or as the ball has been in the past. So based on that information, do we want to classify this study as descriptive or inferential? Well, this is going to definitely be an inferential study because of the note that we circled here in purple, that they randomly selected 85 baseballs. They didn't select every single baseball. They just took a small portion of the entire population, which in this case is all of the baseballs in Major League. They just looked at 85 of them. So this would be classified as an inferential study. And this is going to lead us up to what I mentioned earlier about observational studies and designed experiments. So an observational study, you just simply sit back and you watch as things unfold, and then you interpret the data that's provided throughout the course of whatever that event might be. With a designed experiment, you actually set up basically just what you would think of when you hear the term. You would set up some kind of experiment, and then you would observe the data from that experiment and interpret that data based on the observations during the experiment itself. So in an observational study, let's look at this right here. Observational study, someone is observing the data that already exists. In a designed experiment, the data do not exist until someone does something that produces that data. So for example 3, we're going to determine whether or not this is an observational study or whether it's a designed experiment. So for this example, we're looking at approximately 450,000 vasectomies are performed each year in the United States. And in this procedure, men are essentially rendered sterile. The tube carrying the sperm from the testicles is cut and tied. So there have been several studies conducted to analyze the relationship between vasectomies and prostate cancer. And Dr. E. Giovannucci conducted such a study, and he said that he found in 113 cases of prostate cancer among 22,000 men who they had found 113 cases among 22,000 men who had had a vasectomy, which compares to a rate of 70 cases per 22,000 men who did not have a vasectomy. So Dr. Giovannucci's study shows that there's about a 60% elevated risk of prostate cancer for men who had a vasectomy, thereby revealing an association between vasectomies and prostate cancer. But does it establish causation? And our answer to this is no, we can't make that claim. Even though the data that he has at that time seems to indicate that, it's an observational study. They did not do any experimentation and set up a designed experiment where they could actually compare more pertinent data. So they just simply found 22,000 men who'd already had a vasectomy, and out of those 22,000 men, 113 of them happened to have already developed prostate cancer. They could have had prostate cancer before the vasectomy. They could have had it after the vasectomy. We don't know that information. This is just simply a matter of they found these men. This is the end result of what they discovered in those 22,000 men. And then similarly, the same thing with the 70 cases that they found in the 22,000 men who did not have a vasectomy. So the 22,000 that they found, or where they found the 70 cases that didn't have, or that did have prostate cancer from the 22,000 without a vasectomy, It could be that these men were, they may be taking some kind of medication that would have prevented the development of cancer. It could be that their age is a consideration. Maybe the group of 22,000 who had a vasectomy could be younger, could be older than the group of 22,000 who did not have a vasectomy. So this is strictly observational. They did not establish parameters and guidelines for the group that they wanted to study. So this would be just a simple observational study. I don't want the highlighter anymore. This is observational. So there's a lot that there's useful information, but we can't really make a lot of determinations about what that information tells us. With the fourth example, we're talking about folic acid possibly reducing major birth defects. So two doctors, Doctors A.E. Zeisel and I. Dudas of the National Institute of Hygiene in Budapest, they conducted a study that provided, and right there we already can see, when it says they conducted a study or directed a study, that provided the strongest evidence that we have to date. Those three little words that I circled, we already know that this is a designed experiment. They wrote a paper, Prevention of the First Occurrence of Neural Tube Defects by Periconceptional Vitamin Supplementation. Again, this will be posted on the website if you want to read it. I have a feeling many of you probably won't, but if you want to, it'll be there. But for the study, the doctors enrolled 4,753 women prior to conception, and they divided them randomly into two groups. One group took daily multivitamins containing 0.8 milligrams of folic acid, and the other group only received trace elements, and that would have contained copper, manganese, zinc, and vitamin C. A drastic reduction in the rate of major birth defects occurred among the women who took the folic acid, 13 per 1,000, as compared to 23 per 1,000 for those who did not take folic acid. Does this study imply causation? Because it was a designed experiment and because the results did show that taking the folic acid reduced the number of birth defects or the rate of birth defects among these women, then we can actually say with a greater degree of certainty that yes, folic acid is important to the prevention of birth defects. And we can say this because of the way that the doctors established this experiment. They didn't just observe 4,753 women that they randomly selected. They actually put into place criteria and methods that they were evaluating to see what the end result would be. So with this particular case, we're looking at a designed experiment. And in this case, it does imply causation because of the methodology applied to the experiment. So that's our introduction to statistics. There may be some questions. I know it's hard to do this virtually sometimes, but we're gonna make this work. We will have 3 class meetings a week, and then you guys will be able to ask me questions about these videos. I'm not going to lecture during our class meetings. I'm going to simply answer questions and go over topics that you need further clarification on. So if these videos, if there's something in the video that gets confusing to you, make a note of it, and then we'll talk about it the next time that we meet. But for your homework problems, this video will be posted on the 17th. So this homework will be due on the 20th. I'm going to try to set our homework dates 3 days after it is assigned. So 3 days should give you plenty of time to get it complete. There may be cases sometimes where I extend those dates and maybe give you a week. But for this one, you're just taking the first 4 terms and you're defining them. And those definitions are in our notes. For the next couple of questions, you're just going to simply classify the study as descriptive or inferential, and you're going to explain why you chose that solution. A big thing in statistics, defending your answer. Right, wrong, or otherwise, if your defense of it is strong, then you can earn point in the case of this class, you can earn points for that answer, whether even if it's incorrect. And let's see, and then the last three, it looks like, yeah, the last three problems, you're looking at telling me whether or not a study is observational or it's a designed experiment. And again, you want to justify your answer. So explain why you chose that this was observational or why you chose that this was designed. I hope that this is helpful, this delivery method. Any questions that you guys have, you can reach out to me at any time. You don't have to wait for class, but we'll talk again on Wednesday, and we're just going to keep plugging along. I hope everybody has a great day.